So we will finish the questions that we were working on. Well, the video is going to be all crinkly sounding today. And we have to be careful with these questions. So this one we were almost finished but didn't quite finish last class. And this question said, find the term. So what I'd like to do is I'm going to highlight that because sometimes you're going to get questions that say find the term, and sometimes you're going to get questions that say which term contains x to the 9. The which term is easier because then we would be done. Because first we said we don't know k, we wrote out everything we knew in the formula. I circled in blue everything that was coefficients-wise, because the only hint the question said to us was we know that it has an x to the 9. So we ignored the coefficients and said, on this side I have an x to the 9, on this side I have x's. Here this x squared, it would be in my numerator, here this x is in my denominator. But this x squared is to the power of 9 minus x, so when I use my power rules, I get 18 minus 2k. And this x is to the power k, so I get an x to the k on the bottom. And we do the same strategy we used in our logarithm units, where we got the bases, a single power with the bases the same on both sides. So we could say, so the exponents have to be the same, and we could solve for k. Now, if it was the purple question, you'd be done. Because if k is 3, then you know that it would be term 4. But since this question said find the term, we now have to actually go and find term 4. Okay. So now I go back to the main formula, go back to the regular question, but now I know I want to find term 4. So it's going to be 9 choose k is 3. Your a value was 3x squared to the power of 9 minus 3. And our b value was negative 2 over x. And that's to the power of 3. Again, simplify each of these separately. So go to your calculator. Nine, choose 3, 84, and whichever scientific calculator you're going to be using for the exam, make sure you know how to do the combinations button on that calculator. This exponent is going to be the 6, so 3 to the 6 is 729, and x squared to the 6 will be x to the 6. Well, x to the 12, sorry. X squared to the 6 will be x to the 12. And here, negative 2 cubed will be negative 8 and x cubed. So we can multiply our numbers together. We get negative 4, 8, 9, 8, 8, 8. And we have x to the 12th in our numerator, x cubed in our denominator, and perfect. We get a term with an x to the 9, which was what the question was asking originally. Find the term containing x to the 9. So again, when you're looking at the wording, this question said find the term. That doesn't mean you just say which term it is. After you find out that it's term 3, then you have to go on and say exactly what, once you found out it was term 4, then we have to go on and say exactly what term 4 was. Okay. So in the difficult ones, we did last term, middle term, we did term containing. So this is an example, find the term containing an x to the 9. And the last one that we're going to do is a constant term. And it's very similar to find the term containing, would look like this. Find the constant term in the expansion of, and this time I'm going to have 5x cubed minus 2 over x to the exponent of 12. So, every year this happens on the test. I have someone put up their hand, maybe because they weren't here today. This is a bad day to miss for that, because I'm pretty sure I have one like this on your test. And they put up their hand, and they say, what does constant term mean? And I say right now, the only thing I'll be able to tell you is, well, the exponent is 12, there's 13 terms, find all 13 of them. Simplify them and see if one stands out. Other than that, I can't tell you because this is a test. But a constant term is a term without any x's. And as far as exponents go, that's like finding no x's would be an exponent of 0. That's our hint, and this makes this identical to the question we just did, where we tried to find the term containing x to the 9. To find the constant term, you're trying to find the term containing x to the 0. So again, what does our formula say? Our formula says that tk plus 1 is equal to n choose k, a to the n minus k, and b to the k. And we don't know what k is. So we put in everything that we know. We know that there's going to be some number with no x's. So I'm going to put an x to the 0 there. We know the n is 12. We don't know k, so I'll keep k in there. I know my first term is 5x cubed, and that would be to the 12 minus k. And my second term is negative 2 over x, and that would be to the exponent k. And just like in the one where we had an x to the 9, we temporarily ignore all the coefficients. So if we just looked at our exponent, we have an x to the 0. And sometimes you can do these just in your head. Sometimes they're difficult, but it's not bad to see if you can figure out. Let's do a little mental math and see if we can figure this one out in our head. A really good mental math strategy to figure it out in your head is to pick a number you think is not going to work. You think 4 is going to work? No? Okay, let's try 4. If I put a 4 in for k, can you see that this exponent's an 8? And that would give me x to the 3 to the 8 would give me x to the 24 in my numerator. And if this is a 4 here, I would have x to the 4 on the bottom. Do all my x's cancel out? No. Great, because that was a terrible choice. 4 is the wrong answer. But it gives you a hint. What do you need more of? Do you see you need more on the bottom? So on your next guess, would you guess something less than 4? I hope not. You're a little bit educated now, right? I want the x's all to cancel out. So 4 wasn't enough. So what number would you like to try next? Something bigger than 4. Pick a number bigger than 4. 6. So if we tried 6, can you see that 12 minus 6 would be 6? X cubed to the 6 will be x to the 18. And I have x to the 6 on the bottom. Was it enough to cancel everything out? Now the next guess someone's going to tell me is the right number. So, what's going to work? A 9. So if I put a 9 in for k, this will be 12 minus 9, which is 3. X to the 3 to the 3 will be x to the 9 on the top, and this will be x to the 9. Perfect. So do you see how the guessing and checking with just trying anything to see what happens, right? Sometimes you have to get mad because you actually accidentally choose the right one to begin with. But your goal is to pick the wrong one to sort of realize what's going on. And then you make an adjustment, you might try something else. Sometimes you like see the adjustment right away, you can see that k has to be 9 right away. So it is possible, k is 9, so we want to find term 10. We could work from here. But sometimes on the exam they say solve algebraically, then they don't like you guessing and checking. Then what we're doing right here is the algebraic part. The algebraic part says if I ignore the coefficients and just look at my x's, I have some x's, right? Those would be the x's in my numerator, and these would be the x's in my denominator. If I use my exponent laws, I would multiply here and subtract here. You see you'd have 33 minus 3k minus another k would be 36 minus 4k. And at this point, we can go, so 0 has to equal 36 minus 4k, and it's not hard to solve from there. That k is equal to 9. Now we should go back to our question. Did the question say which term is the constant term, or did it say find the constant term? And if we go back, it says find the constant term, so now we actually have to go and solve for term 10. N was 12, so we have 12, choose 9. We started off with 5x cubed. To the 12 minus 9, and negative 2 over x to the 9. Again, when using the formula, simplify each of these on their own. So go to our calculator. We get 220. 5 to the power of 3 is 125. X cubed to the power of 3 is x to the 9. Two to the power of 9, well, negative 2 to the power of 9 is negative 512, and we would have an x to the 9 on the bottom. And what we wanted was for those x to the 9s to cancel out. And if we multiply this all out, and you will find in this unit, you do get some very big numbers. That term has no x's. It is the constant term, and everything has canceled out. Question?
I'm confused where you get the 0 equals 36 minus 4.
After we're at the green, if you have a power on one side with the same base as a power on the other side, and it's equal, does it make sense that the exponents have to be equal? That's where I got the 0 equals 36. Just like we did in our logs unit. Okay, questions for practice? Circle number 9.